In the second tutorial of our V8 engine series for beginners, we will model the engine block. This will be presented in two parts, as there will be a lot of fundamental principles of design taught, including how to create a new component, extrude tool basics, sketches, circular pattern, two-sided extrude, how to change the material and appearance, and so much more. Welcome to the Learn It channel. Let's make the engine block. Let's do a sketch on this face. I can just right-click it and go create sketch. Make your life easier. Remember all these different shortcuts. Sheet 1 is done. Let's move on down to sheet 2 now. So basically we're going to take this, and there's a lot of little details here that you probably will miss, but that's why we're doing this together. We're going to learn how to read drawings and make them right. So first thing we're going to do is look for the root sketch feature that everything else is based off of. And if I look really closely, I see that the first cylinder bore has a lot of dimensions coming off of it. So that's the one I'm going to pick. Let's go center circle. I'm going to place my mouse cursor right here on the x-axis. Here's a fundamental thing within Fusion. Despite our mouse cursor snapping to the grid, it doesn't mean that it is constrained. So if I create a circle right here, don't worry about the dimension. I guess I could put it in right now, but don't worry about it too much. Okay, look at our center point. It's not constrained to anything. So even though I snapped it to the x-axis, it's not constrained to it. It's not snapped to it. We have to snap it. So go to your horizontal vertical, grab your center point, grab the origin, and now we're getting rid of its degrees of freedom. We can move it left and right, but we can't move it up and down. So that's perfect. That's all that constraints are. We make sure we are accurate and our design is perfect. So this is perfectly in line with the center. Now, where's our dimension coming from? D for dimension, grab the outside edge and the center point. We can actually click anywhere on the circle in this instance. Because a circle has an infinite amount of points, Fusion recognizes when we pick a circle, it selects the center point for us. So I'll prove it to you. There we go. Little side point, everyone, little side point. If we want to go to the point of tangency on the circle, go D for dimension, select the line, and before we pick the circle, right click. And here you go, pick circle arc tangent. And then we can pick any point on that's tangent. So it's either this or that side. And here we can specify that little dimension right there if we want. But Fusion defaults to just the center point. So there we go. Place the dimension where it is on our drawing, 1.1875. Awesome. Why is our sketch still not constrained? What's missing? The diameter. So let's grab this, move it on down, 1.75. You see that we can't make our sketch within Fusion look exactly the same as our drawing, and that's okay. Basically, we're trying to put our dimensions in approximately the same location, and that's just for visual reference to quickly scan with our eyes, are all of our dimensions accurate. You'll notice here 1.188, if we hover over it, Fusion just defaults to 3 decimal places. So if you hover over it with your mouse cursor, you can see 1.1875, so that's accurate. And what I always like to do with my students is I like to encourage them to highlight or check off each dimension so we're not missing anything. Great, let's keep on going. We see that these 4 bores are equally spaced 1.875. So why don't we do that now? Let's go create, and I'm going to go to rectangular pattern, select the object, and now let's talk about this. This frustrates a ton. Here we have 2 different directions. We've got a quantity of 3 and a distance, and we've got quantity of 3 and a distance. Both of them want to go one direction. Instead of fiddling with this dialog window, grab the arrow of the direction you want to move in. So I'm going to grab that. There we go. Let's go like that. How many bores do we want? On our drawing, it says 8, and that's including the 4 on the other side. Okay, so let's go quantity of 4. And now instead of extent, so that's from center point to center point, that's the extent, I want to go to spacing. And now you can see we have a couple different ways of inputting this. We have this little dialog window right there, and we have this big one over here. They're exactly the same thing. This is just closer to our mouse cursor. So I'm going to type in 1.875, just like that. Enter. Everything is fully constrained. This is looking great. This is looking really cool. Now, here's a funny thing. Remember I talked about the dimension being placed over here, where on our drawing it's over here. Why don't we just switch it? Now that we've patterned that, let's delete that. All of our circles turn blue. Now if I constrain or dimension this 1.75, all of them turn black. All of them are fully constrained because they're copies of each other. That's what patterning does. Very good. Let's keep on going. There's a million things on our drawing here, so let's figure it out together. This is great. So I'm going to, because I've already designed this, I know how I would approach this, but you might approach this a different way. So I encourage you to pause right now, try and do the rest of this, figure out what's going on in the drawing if you can, and try and design it. It's extremely easy if you know the technique. If you're ready, let's keep on going. I'm going to create an offset right now, and I'm going to pick this entire rectangle. Move it on in, and you can see we've got a value right here. This is minus 0.16. On our drawing, it says that there's 36 times that. Well, when you calculate all of them all the way around, there's 36 features that have this dimension on both top and bottom. So I'm going to go minus 0.16. It's minus because it's inside. On drawings, you never really see a negative integer. I don't think I've ever seen one. So you have to interpret that within Fusion. So I'm going to go minus 0.16. So that's 1.6. Bring it all the way on over here. There we go. Let's put it up there. It won't allow me to put it over off to the right here. So 0.16. Now here's the thing. This line on this side, let's put it in, is not 1.6 away. This is the special exception. So if I go D for dimension and I go like this from there to there, perfect. This is 0.66, just like that. So that looks great. Let's not try and overlap any dimensions. Sometimes ones will put their dimensions like this and you can't see it. So just make your sketch look pretty. If it looks pretty, it will work. Okay, very good. So what else do we have? This represents all those different features around our drawing, but then we also have some radiuses, 52 radius, 64 radii, I should say. So let's do that. Center diameter circle. These are our bores, right? Let's go in and create the other ones as well. This one here is going to be a radius of 1.03. So remember how to turn this into a radius. D for dimension, select our circle, right click, radius. Okay, this is going to be 1.03, just like that. And then we have our 52 times radius specified there as well. Now, what this is representing are the inside of all those profiles. So why don't we do this? I also would like to pattern this circle down the line. Very simple. Go into your pattern, right click. We can edit it or we can double click. It's the same thing. Objects. If I want to copy an additional object, hold down Command and select the other circle. And that adds all of them right there. Brilliant. There we go. This is looking really good. Next, I would like to put in all of our bolt holes. So this is a little difficult, but let's just have fun with it. I'm going to use this center diameter circle, and I'm just going to specify it right here on the corner. And this is the radius of 0.1875. So there we go. I'm just going to select it just like that. D for dimension. Grab that circle, right click, radius, and I'm going to call this 0.1875. Now I think I've made a mistake, so I'm going to update this with the drawing. I believe this is actually supposed to be 0.375. Yeah, that's the way it's supposed to look. No, actually, I'm sorry about that. Let's fix this. This is supposed to be 0.1875, but I've placed the center point at the wrong location. So what I'm going to do is I'm just going to delete this, because if we want to move a constraint, we have one of two constraints over here. I could delete one. Actually, that was the correct one. No, it wasn't. You can see this circle is still constrained to that endpoint. So that was the wrong constraint. I can try the other one. Yeah, there we go. Okay, so let's just do that. You can recreate a circle right there, but the endpoint doesn't belong right there. That was my bad. Here we go. Let's specify the dimensions. D for dimension, center point to center point. Do you see what this value is supposed to be? It's supposed to be 0.75. This value to the center point, the horizontal value, is supposed to be 0.9375. There we go. So this is actually going to be the cutout. This is the other cutout right there. This is looking great. Very good. Now here, we're going to pattern this sketch entity all the way around right here. And this is going to be fun. Let's go to create rectangular pattern, pick our circle, and here we have two directions. So I'm going to go this direction first of all, and then pull your arrow down. Pull it in the direction you want to go first, and then adjust the values after. So in our down direction, change this to a quantity of 2, and we can even pull it into place. Let's grab our dimension right here, and this is supposed to be 0.75 times 2. This is where we have to do a calculation. We're going downwards, so it's a negative value, minus 0.75 times 2. Now in our other direction, don't hit X yet, or don't hit enter yet. Grab our arrow, and how many do we want? Quantity of 5. And the distance between each of them is the same as our bore, 1.875. There we have it. And you can see they're all perfectly placed right here. So this is looking really good. Enter. One mistake I've made, this 6,6 dimension over here is not from this edge, but from the outer edge. So I'm going to delete that. Just grab your arrow, pull it back a little bit, doesn't really matter. D for dimension, select those two lines, and this is supposed to be 0.66. So all of these closed profiles are going to be cut out. Otherwise, I think that we've got everything on their screen. Now, one thing you'll notice is that there is a bracketed dimension, 2.125. So if I go D for dimension and I select this line and that line, this will be a driven dimension. So it's based off of something else we've already defined. And that's why we see a bracketed dimension on our screen. If it's defined in another drawing, then you'll see in our sketch, this should be also a driven dimension. So that's what that's referring to. This is great. Let's go finish sketch. Now we've got everything representative of what we want to cut out in our part. Now, do we go ahead and use the extrude for these? We could. There's nothing wrong with that, but I'm not going to use extrude. I'm going to use the hole tool. The reason is when we use the hole tool, this has a bearing on our drawing in the future. When we look back at our drawing, you can see, for example, the 1/4 inch 20 definition. That's all automatically inputted by Fusion. It makes life a whole lot easier. Rather than inputting all those symbols and all that structure, well, Fusion does it automatically and it does it professionally for us. So I would like these cylinder bores to use the exact same method. So let's click on the hole tool. I'm going to pick the center of all of these. Very good. Distance, let's leave this for a second. We want simple, that's fine. Hole tap type, simple, 0 point, don't worry about this. We just want to focus on the diameter. It's supposed to be 1.875. Now go distance, and we're going to go all. So now this goes all the way through right there. This is looking great. And Y is our dimension a little bit off. That's why, because it's not 1.875, it's 1.75. There we go. All right, perfect. We've gone all the way through. On our drawing, it's now not going to specify a distance, because the distance is actually right here, 3.435. We don't want a distance. We just want to say to go all the way through. And that's what Extents does for us. So let's go OK. Our sketch now disappears. That's fine. Let's go back to it. We should rename it at this point, and I'm going to call it something like our cylinder bore face sketch. There we go. Let's bring it back. Let's make it visible by clicking that eye. Everything comes back. Let's put in our other holes, our tapped holes right now. So we'll go back to our hole tool, and I'm going to pick all these other points. And don't worry about how big the hole is right now. That's fine. Just pick all of your points, just like that. And now we are going to just go down the line here. This is actually a countersunk hole. That's what you see, that V on our drawing, 0.25 by 90. So go countersink, and let's just put in our values. This is actually going to be 0.25 by 90 degrees. The depth, do we have a depth here? Yes, it says down 1.75. 118 degree, we don't really worry about that. That's just dependent on our drill tip. And then our diameter. We don't need to put in a diameter here because we're actually going to go to tapped. Fusion assumes that we want a number 12-inch tap. We're just going to pick that size and change it to 0.25, which is a 1/4 inch. Supposed to be 1/4 inch 20. This is looking great. And when we look at our drawing right here, you can see, or our sketch, I should say, our 3D model, you can see that we're going down 1.75 inches. Everything is great. Class is 1B. We are good to go. Let's go OK. Here's another tip. We had to make our sketch visible to see this sketch again. Once we've made it visible, Fusion will keep it visible. Our first extrude or anything we do on that sketch, Fusion will automatically hide it. It assumes that we don't want to use that sketch anymore. But here we want to use it, so we've made it visible. And we're going to keep on using it to create the other features as well, the other 3D features. And where are those? So each of these closed profiles right here, the dimension is somewhere. Can you find it on sheet number 3? Well, there it is, 1.5 inches deep. So I'm going to select all of these different closed profiles and then extrude them 1.5 inches in. So this is going to take a while to select all of them. Let's speed it up. Okay, now that I've selected all of them, I can go down. And here, if you don't know which way to go, just grab your arrow, bring it on down, and it shows that it's a negative value. So this is supposed to be negative 1.5. Press enter. If you've accidentally picked the wrong closed profile, don't worry about it. Just go into your extrude in your timeline. And here you have 26 selected. Let's assume that you've maybe accidentally selected that. Oh, well, we don't want to extrude that. So go back to your extrude, hold down Command, and click it, and it will deactivate that closed profile. So go OK. Now we want to hide the sketch, and this is looking great. This is looking really, really, really good. So just before we move on, let's talk about our sponsor PCBWay for a moment. Let's say that you want to get this 3D printed or you want to get it CNC machined, but you don't have the equipment. Really simple. Let's just go to our engine block, right click, and we're going to export. Let's export this as a step file. Once we do so, we're going to head on over to PCBWay, click on CNC 3D printing, move over to the 3D printing tab, get started, drag and drop our file. I've worked with PCBWay for quite some time now. They do great work. They always make the customer happy. So if you're interested in getting this 3D printed or CNC machine, check them out. Thank you, PCBWay, for all your support. Okay, so at this point, this is where the benefit of using mirroring, or better yet in this instance, circular pattern. What is the difference between both of them? Well, using mirroring will actually create completely different holes and features on the other side. It's like a brand new body. They're not the same. Although they look the same in this instance, remember that mirroring creates a brand new body. We want to go to pattern. And although we don't want rectangular pattern here, look at what happens. If I click on that, we can actually pick other options of our pattern. And that's in the create drop-down menu as well. hovering over pattern, we have a bunch of different patterns that we can pick. Well, they're right here as well. Let's go circular pattern. I'm going to keep it on bodies, and I like to pick this body. And now here's the whole point of drawing this and building it around the origin. So let's go axis. Our origin shows up, and I want to pick the Z axis. Now this is putting 3 bodies in. So let's just change it to 2 bodies. And now look at this. Let's go 2. Now look at the difference. You can see that this body over here, we've got a short distance between the sidewall and the bore. And here is a wide distance. Same thing over here. Here's the wide distance and here's the short distance. That's exactly what we want because our crankshaft and our piston assemblies need to be staggered. That's how an engine works. So that's why these cylinder bores are staggered a little bit over here. But the reason how we can do that so easily is by creating a pattern using the circular pattern tool. Now that it's hard to wrap your head around that we're using, these rectangular looking parts and we're using the circular pattern tool for them. But that's exactly what we want. We wanted them to revolve around that Z axis, that Z axis right there. Now, how many bodies do we have? We have 2 bodies. So I, in fact, want to combine these into 1 body. So I'm going to go up here to our Modify menu, Combine. The target body, keep it as body 1 as our target and our tool as body 2. It assumes that we want them joined together. Let's go OK. And now we have 1 body again. That seam disappears halfway down our engine block. And let's just look at our timeline for a second. Look at all the things that we have here. This is everything we've used to create our engine block so far. So our first sketch, our body sketch. This is our first extrude. This is the cylinder bore face sketch. If we hover over that, it actually tells us which one it is. We've got our cylinder bores. We've got our bolt holes. We've got our extrude. Those are a little release right there. Our circular pattern wraps that body around and then it joins the 2 together just like that. So this is looking great. Now, what else do we need to do? We need to hollow this body out on the inside. So let's do that now. Let's create another sketch. I am going to create it. And actually we can create this on any face we want. Just to prove it to you, I'm going to do 2 different ways. Let's pick the XZ plane. Now we've got this body right here. I'm going to go slice and we can see right through. The problem with doing this is that it's a little complicated. It's hard to see our sketch profiles that we want to create. So instead of doing it this way, feel free to try it if you want. It's okay. I'm going to go undo that sketch. I'm going to create another sketch on this face. Now, I am going to create this as a hexagon. So let's create a polygon and we can just do an inscribe polygon, start at our origin, move this on over, and this dimension is supposed to be 1.825. Just like so. Is everything locked in? No, this needs to be horizontal. So actually, hold on a second. It needs to look like this, doesn't it? So this line right here needs to be vertical. So let's just click it, vertical, horizontal constraint. It automatically applies this vertical constraint to it. And this dimension is actually wrong. I picked the wrong type of polygon. So I'm going to delete that. And now it's very simple. Just go D for dimension. Go from the center to that line. There we go. 1.825 is the dimension. It also has a reference 0.3. This is just to verify that we've done this right. So create a driven dimension, brackets just like we see on our drawing, 0.3. This is looking great. So let's finish that sketch. And now what we can do is use this close profile to do the entire cutout of our engine. But obviously we don't want to go all the way through, so I'm going to show you a brand new trick here. Let's go to Extrude, grab that profile, and here's a little tip. So we want to go this direction, right? But instead of one side, I'm going to go 2 sides. And usually we think of 2 sides going one way and the other, but in fact we can grab 2 sides and go in the same direction. So the first one, This is going to move on over 0.25. So the cutout's going to start 0.25 from that wall. And this one over here, look at this. Instead of doing the math, let Fusion do the calculation for you. Instead of distance, go to object, pick that face, and then we've got an offset over here, minus 0.25. There we go. So we've got this beautiful cutout. Let's go OK. It hides that sketch. We've got this entire block looking great right now. Let's just rename that sketch over here, and we're going to call it the inside shell maybe. Call it whatever you want. This is just to easily refer to it later on. It's best to get into good habits with correct naming conventions and things like that, but don't worry about it too much in this course. The last dimension that we're missing is 26 with a radius or a fillet of 0.25. So we're going to grab our fillets. Always save the fillets to the very end if you can. And here we're going to go and pick all these different edges. So let's just pick these 1, 2, 3, 4 first of all, and I'll show you why. We actually need to pick all these different edges as well, but by picking these long edges first, it's going to turn this line, that line, and that line into a tangent chain, and it's going to make our life a whole lot easier. So let's go 0.25, just like that. And now if we go back to fillet, look at this. If we pick that, it actually selects 5 edges with 1 click. Boom, that's 2, 3, 4, 5, and we can actually look through our part if we can. This is kind of hard, so we're going to have to rotate. That's probably easier, or orbit, I should say, and call that 0.25. So that's it right there. That is our entire engine block. Now we're not quite done yet. We have one more thing to get to. Just before we finish up, I'd like to send out a huge thank you to all of our Patreon and YouTube members. Thank you so much for your support. You're helping greatly, and I know that you're benefiting greatly. It's a win-win. Thank you so much. And remember, for all of our Patreon members, you can get the official PDF as part of your membership. Just head on over. You'll see a link to that in the description below. So the last thing we're going to do here is we are going to turn this engine block. We want to make it accurate with its material. So let's just minimize these folders, the bodies and sketches. Under engine block, I'm going to right click, and let's first of all go to physical material. Here, we're going to go to metal and find aluminum. Let's just go regular aluminum, drag and drop. There we go. The default in the system is steel. It has to have steel in the design if that's our default. We've added aluminum, which is great. But I'd also like to add an appearance, and I'm going to make this engine block red. So let's go A for appearance. Just to let you know, you can also go right click on engine block and go appearance. You can also go right click anywhere. And I believe appearance is there. No, it isn't. Right click on any aspect of our design. You need to click it first, and there's appearance down there. But just get used to A for appearance. A, there we go. I have selected in my favorites, I've got the plastic matte red over here. I've got other reds, but I don't want that. I would like to save in my Fusion appearances as a favorite. I'd like to save a new type of appearance. So if I go to paint, let's go there and let's go to powder coat rough. Here we go, powder coat rough red. I kind of like that. I would like to use this, so I'm going to drag it up into the design. Let's not apply it yet to anything. And then in fact, I want to right click and I can add it to my favorites. So now when I go to my favorites tab, there is the powder coat rough red, perfect. But I don't want to add this red to everything. I just want to add it to the external faces. So I can go faces, and then I'd like to add it. Now, I could do one of two things. I could make it all red and then add the aluminum satin appearance to the places where I don't want it to be red or machined, or I can just add this later. And I think I like this more. Now, what I'm going to do is let's just go to front. If I select, let's go escape there. A for appearance, faces. Oh, and this won't let me over here, so that's fine. Let's just go faces, and I'm going to pick all these using Control on Windows or Command on a Mac. Let's just select all those faces and drag and drop that red right there. And I'm going to repeat this all over. We can just go like this too. Drag and drop. There we go. Let's pick the other ones on this face, or on this side I should say. And there we have it. So everything else is going to be machined. I think this is looking great. That's exactly how I want it right now. And make sure to save. And we should have actually been saving all along the way. So at this point, remember, we are going to save the little aspects, the little features, the little details of this, such as chamfering, for when we do the renders, because for our drawing package, it's a whole lot easier to read when we don't have a million chamfers on our part. So instead of adding them right now, we're going to save that to when we start getting into rendering. But for now, this is our finished engine. So if you've benefited at all, please comment below. If you love our channel, please consider subscribing. Help support us by getting the word out of our channel. Hope you stay tuned to the next tutorial when we're going to get into the oil pan. Let's just take a look at that real quick. In our render over here, I'm going to find the oil pan. Where is it? There it is, isolate. And here is the oil pan that we're going to work on. So this is going to be really cool. Hope you stay tuned for this. And again, if you want to become a member, please consider that. We'd love to have you aboard. But hope to see you at the next tutorial. Thanks again for tuning in.